I am Dr. Muhammad Sirajul Faisi. Welcome you in my YouTube channel. Today in this video, I am going to talk about elimination reactions of alkyl halides, competitions between substitution and eliminations. This material I have taken from the website Organic Chemistry 6 editions Paula and Bruce. So look at these molecules. Here is the chlorine, and you look at here the situations, more density, and this is the nucleophile CH3O minus. So after eliminations, forming this trans, and this is the cis products. Now friends, in this slide I am going to discuss about, in addition to substitutions, an alkyl halide can also undergoes elimination reactions. So CH3, CH2, CH2X and this Y minus nucleophile, if substitutions occurs, then this product will form, and if eliminations occurs, then this product new double bond forms. So there is a 2 byproduct here, 1 byproducts. Now what is the E2 reactions? So some point here I will talk about the reactions and mechanisms, kinetics, stereochemistry of E2 reactions, reduced activity, substrate structure, base, living groups and solvents. So friends, this is examples of E2 reactions. This compound is known as 2-bromo-2-methylpropane, undergoes nucleophilic eliminations, so forming 2-methylpropene. This is here double bonds. So hydroxide cannot act as nucleophile in these reactions because of the bulky tertiary halide. Rather, hydroxide act as a base and abstracting protons. Now friends, in this slide I am going to talk about an E2 reactions is also called beta eliminations or 1-2 elimination reactions. So the situation here is like that: bromine is living groups, base abstract these protons, and this is the beta carbon, and this is the alpha, that is alpha beta or 1-2 elimination reactions. So eliminate this hydrogen and this bromine and forming these products. The weaker the base, the better it is living groups. So it should be weaker base. Relative reactivities of alkyl halide in an E2 reactions: RF, RCl, RBr, Ri greater than RBr, RBr greater than RCl and RF. Most reactive is alkyl halide and least reactive alkyl fluoride. So friend, the removal of protons and halide is dehydrohalogenations. So here a proton is removed, these protons, and bromine minus is eliminated, a double bond is formed. What is the kinetics? The rate is equal to K alkyl halide and concentration of base. Now stereochemistry. Stereochemistry of E2 reactions: the bond to the eliminated group H and X must be in the same plane. You see, this and this substituents are syn periplanars, and eclipse conformation. And here substituents are anti-periplanar, X is here and H is here. So staggered conformations. So which one is good for elimination? And anti-elimination is favored over the sin eliminations. This is favored over the sin eliminations. Now friends, another view of E2 reactions mechanism is base trap these protons. This bond will shift between these two carbon, and this expansion, sin eliminations, front side attack. And now anti-eliminations, back side attack. The best overlap of the interacting orbitals is achieved through backside attack. Backside attack is important. Anti-elimination avoid repulsions of the electron-rich base. Now friend, elimination from cyclic compounds. In an E2 reactions, group to be eliminated must be in axial positions. This is axial position. Group to be eliminated must both be in axial positions. You see, this is equatorial and most stable, OH minus E2 reaction, no reaction. This is axial and this is axial, less stable, OH minus E2 reactions and formation of double bonds. This is very important reactions for net examinations. So equatorial, stable, more stable, and this axial is less stable. So less stable, this is giving the elimination products. Now neomethyl chloride, more stable. This is the axial. Now this group is equatorial. So, and this is less stable. You see, this is axial and this is equatorial. So elimination occurs more stable. This is your ethoxide E2 conditions and forming this product. This is also a very important reaction for NET examinations and of course JAM also. Now methyl chloride more stable, and this is the less stable. This is, you see, axial, equatorial, and this is the axial. Both are in the equatorial plane, and this is the axial and this is also less stable, and this product give this, and this reactant, this product, this E2 reactions forming these products. This is also very important reactions, and I think in many competitive examinations that questions put or. Now the hydrogens that is removed and the living group both have to be an axial position. Therefore, you see Cl and CH3 more stable than CH3 and Cl, axial and equatorial. This is axial, so less stable. It undergo E2 reactions. You see the formation of these products. Now K equilibrium more stable conformer divided by concentration of less stable conformer, large number and a small number. K equilibrium less stable conformation, more stable conformation, a small number and large number. For reaction that take place through the more stable conformer, for reaction that takes place through the less stable conformers. So this is the formula. You have to remember this formula. This formula is important for the competitive exam like NET and GATE. Now the challenging topic, eliminations of 2-bromopentane. Consider the stereochemistry of E2 reactions. This is the trans, this is also trans, BRHR NT, BRNHRT. So give more stable these products, and if BRHE and this situation is like that, then Z2 pentane less stable. This is also very good examples for exams. The alkene with the bulkiest group on opposite side of the double bonds will be formed in greater yield because it is the more stable alkene. Now you see 2-pentene, the electron density situation is like that, and Z2-pentene, the electron density. So interactions electron clouds cause steric strain. You see here no strain, here strain. There is interactions between this electron density. We called it steric strain. Now reduce selectivity of E2 reactions. To reduce selectivity of E2 reaction, the major product of E2 reaction is the most stable alkane. Look at here, beta carbon, this, and this is methanol solvent. It giving mixture of E and Z is 80% 2-butene and 20% only 1-butene. So there is a rule, that rule is known as Jetsev rule. The more substituent alkene product is obtained when a proton is removed from beta carbon that is bonded to the fewest hydrogens. The most stable alkene is generally, but not always, the most substituent alkene. Now, relative reactivity of alkyl halide in E2 reactions. Look at here, tertiary alkyl halide greater than secondary alkyl halide greater than primary alkyl halide. So here is the formation of double bond, here is the formation of double bond, here is the formation of. So 3 alkyl substituents more stable, 2 alkyl substituents 1 and 2, and 1 alkyl substituents are. So it depends on the situation of alkyl halides. Now you see transition state leading to 2-butene, this is the more stable, and this is the less stable transition state leading to 1-butene. Now exceptions to Jetsev rule. What is the exceptions? Based on substrates, conjugated alkene products are preferred over more substituent alkene products. So you see this is double bond. So it is undergo elimination reaction forming these products, major product, and this is the an isolated diene because double bond is not in conjugations. Now you have this reactant, it gives these products, it is in conjugations with respect to this minor product. So do not use Jetsev rule to predict the major product in this case. Now based on the base, bulky bases affect the product distribution research. The Hoffman product, the least substituent alkene. You see approach to the hydrogen is a sterically hindrance, this, and bulky base, third butoxide ion, and 28%, 72%, and this is the Jetsev products, and this is the Hoffman products. So there is a difference between Hoffman products and Jetsev products. However, it takes a lot of steric hindrance for the less stable product to be major products. So you see 79% and this is 21%. Now you have these substrates and you have these two products. So if you have this base, you will get the more substituent alkene and less substituent alkene. So in that case 79%, in that case 27%, you see it's increasing less substituent alkene. So friend, this is also an important table for E2 reactions and for competitive exams based on leaving groups. Now another exception of Jetsev rule is leaving groups. You see X is here forming mixture of E and Z and forming one hexane. So now leaving group and conjugate base pKa, more substituent products and less substituent products. So you see that 81% if I is there and 90%. If you have reverse fluorine, then 30% and 70%. So this table is very informative for JM and GATE examination. Consider the elimination of 2 fluoropentenes. This is fluorine and formation of 2 pentene 30%, you see, and this 1 pentene 70%. The carbanion-like transition state, carbanion-like transition state is like that. Transition state leading to 1 pentene more stable, and this is the less stable due to transition state. Now E2 reactions, substrates primary